Energy takes many forms and is involved in all physical processes. Using a bow and arrow, these transformations in energy can be demonstrated. To pull the bowstring back, a force is exerted over a distance and work is done on the bowstring. Through this process of work, energy is transferred from the person doing the pulling to the bowstring. After the string is displaced, the energy has not disappeared, but is stored in the bow as potential energy. Upon release, the stored energy in the string is used to do work on the arrow. The arrow is accelerated, and potential energy is converted to kinetic energy. Within the bow and arrow system, energy takes on different forms. Transformation between these different energy forms is always accompanied by the performance of work. To quantitatively study the energy changes, the work which is done on the bowstring will be determined using force and displacement measurements. By recording the data points and plotting force as a function of displacement, the work done by the steadily increasing force can be determined graphically. The relationship between the applied force and displacement is observed to be linear. The amount of work done can be determined by finding the area under the curve. In this case, the area is simply that of a triangle, and the amount of work is calculated to be 9.5 joules. This is the amount of chemical energy which is transferred from the person's arm and stored as potential energy in the displaced bowstring. When the bowstring is released, the arrow gains kinetic energy. The velocity of the arrow is found by measuring the time required for the arrow to travel the 0.75 meter distance between photo gates. Using the measured time interval, the arrow's velocity is found to be 20 meters per second. With the velocity and mass known, the kinetic energy of the arrow is determined to be 9.4 joules. This kinetic energy value closely agrees with the work and potential energy previously measured. It's evident that energy can be transformed from one form to another and transferred from one object to another. However, the total amount of energy remains constant.